Okay, so now let's talk about the probability part. So in this short video, we will talk about 4 different kinds of questions. Okay, 4 different kinds of questions. So this is the case 1. So case 1, the list is given. Okay, the list is given. So the list is given. Okay, so now this is the scores of 10 students. So first you have to write down the set S, right? Set S is an ordered set, so you just reorder the list and then put the numbers in the set, right? Put the number in the set. So these are the possible numbers that we will pick. So this is the set that we consider, right? This is the set that we consider. So now question 1, we look at odd grade higher than 80. So higher than 80 means greater than 80, bigger than 80, right? And then denominator. So denominator is always 10. So that's the total of elements in S or total given numbers. Okay, total given numbers. Okay, so that's denominator. Denominators are the same for these all 3 questions, right? Okay, so we have 10 scores in total, so denominator, we use this 10. Okay, we use this 10. And then different condition for probability give us different smaller set, right? We pick some numbers and then put them on the numerator, and then we count how many numbers satisfy the condition. Then we have the numerator. Okay, then we have the numerator. So question 1, we have 80. So bigger than 80. After you ordered, this is the 4 numbers bigger than 80. Right? You write them down on the numerator and then you count it. You got numerator 4. Okay, so there are 4 scores of 4 students. Their scores are bigger than 80. Okay, bigger than 80. So now for the second case, we want to look at how many students get the score less than 65. Okay, less than 65. So that's the end, right? That's the end of the list. So that's why we have to reorder the list. Okay, reorder the list. Okay, reorder the list. So 40, 61, then we got 2 over 10, right? Then we got 2 over 10. Okay, yeah. So now there's a remark if, okay, so in S we don't double count, right? If there are 2 students get the same number, in S we just put it once, right? Yeah. But if that happened, right? If that happened, we don't put the set notation. Right, you just reorder the list, write down all the given scores from bigger to smaller or smaller to bigger, including the multiple repeating numbers. Okay, repeating numbers. So otherwise your denominator will be wrong. Okay, otherwise your denominator will be wrong. Okay, yeah. So you don't have to write down the set notation. Just give me an ordered list of all the given scores. Right, all the given scores. So now the last one, they said greater than or equal to 60 and less than or equal to 80. So between 60 and 80, 60 and 80 included or not, depend on that what their condition, right? Yeah. If there is an equal sign, that means included, otherwise it's excluded. So that's the middle, right? That's the middle. So you put 1, 2, 3, 4, 5 numbers on top, so numerator is 5. Okay? Numerator is 5. So this is the given list problem. Okay, given list problem. So we use the idea of set S. First, we have an ordered list, and then the total number will be our denominator. And then we look at condition. So how many numbers satisfy the condition? Put all those numbers on top, and then count them. You got the numerator. Okay, numerator. So that's case 1. Okay, so case 2, the list is not given. Okay, the list is not given. You have to make a list. Make an ordered list. Okay, make an ordered list. So this is the example that we are tossing a coin 3 times. So each time we got either H or T, right? H or T. So after you use this tray, make this tray, and then this is the order, right? This is the order of the elements for this set S for all possible cases. Okay, all possible cases. And then you have some conditions. So follow the condition. You'll see how many elements in S satisfied condition, that's numerator. And total number of the possible cases are 8, so 8 is your denominator. Okay, so now let's reconstruct this list. Okay, let's reconstruct this tree. Okay, construct this tree. Okay, so every time we toss it, so first time you may get H or T, right? Let's use red color, and then let's use blue. So this is the second time H or T, right? Second time. Okay, second time. So what did I wrote here? Okay, and then you do it again. Let's use green. So that's H or T again. That's the third toast, right? That's the third toast. So now when we make the tree, so we look at the first case, you have two possibilities, right? And then suppose I got H, you got T. So for me, I do it again. I toss the coin again. I got H or T. So this big red H has two branches, right? Two branches. So same thing, you may also get H or T. Okay? So the sub branches, small pass, just means the next possibility, right? The next possibility. And then the green color, so for HH, I got H in the first time, I got H the second time, and then what's the third time? I got H or T again. Okay, H or T again. So same thing, it doesn't matter what you get in the first or second toes, you always get two possibilities for the third toes. Okay, yeah. So that's our tree, right? That's our tree. So step 1, red, step 2, blue, and then after every blue, you get 2 green. Okay, you have 2 green. And then that's our order set, right? That's our order set. So let's write down the order. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 ends of the tree in the end, right? In the end. So now what's our number 1? What's our first element? We look at the path going backward, right? So the black path, we got H, H, and H, right? So now let's jump to number 5, right? Number 5, let's use purple path, right? Then is H, H, T, right? You can write down the 3 letters from left to right or right to left, okay? So my suggestion is from right to left, okay? Right to left, right? So number 6, so let's change the color, change to red. The red path, so you will got T, H, and T. Okay, T, H, and T. So in this way, you will get all the 8 elements. Okay, all the 8 elements for 3 tosses, right? For 3 tosses, and each element has 3 letters, right? Each element has 3 letters. Okay, yeah. So now this is the practice. You can try the 2, 3, 4, 7, and 8. Okay, 7, 8. So now let's jump back to the list. Okay, so now suppose we got this list of 8 numbers, right? Suppose we got this list of 8 numbers. Sorry, 8 results. Okay, 8 results. Okay, so number 1 to number 8. Okay, number 1 to number 8. So now look at the question. Look at the question. How many results here? How many elements here satisfy the condition? So question 1 is easy. They want THH. Okay, THH is which one? Is my number 2 here. Right? So only this element satisfies this condition. So it's the probability of 1 element, right? THH. So that's 1 element on top. Probability is 1 over 8. So similarly for the last one, right? Last one, this is our first element, right? This is our first element. So what's the probability? When you toss 3 times, you get this HHH, the head 3 times, still 1 over 8. Okay, 1 over 8. So now the middle one. So the middle one, they want only 1 H. So that means you got the head once and tail twice, right? Head or tail. So now it could be, let's find this number, right? TTH. TTH is my number 4, right? And then THT. THT is my number 6. And HTT, that's my number 7. So 4, 6, 7. they are satisfied, the result you get only one head and then two tails, right? Two tails. So now the probability will be 3 over 8. Okay, 3 over 8. So this is case 2, right? Case 2. You make a list and then you look at how many elements satisfy the condition for probability. And then those elements are the numerator. So you count them, that's your numerator. And denominator is number 8 because in total we have 8 elements, ordered elements in set S. Okay, in set S. So this is case 2. You make a list, follow the tree method. Okay, so case 3, you are given a table. Okay, you are given a table. We want to find the probability. So first question, you may find the probability for one letter, right? Probability of D or probability of E. Okay, of E. So you use row total or column total for this one letter probability, right? For probability of D, so use the total of the first column for Democrat, so you got 68. And then denominator is the total of employees, so that's 140. So now the probability for executives, you use the row total, right? Row total. So that's 48 over 140. Okay, so this is one letter probability. You use either row total, row or column total. For the numerator, okay, for numerator. Denominator, we always use 140 except the last case, okay, except the last case. So now the second case, we have two letters, right? We have two letters. Then we may think about the union or intersection, right? Union or intersection. The intersection is easier, right? Let's look at P, D intersect E, right? D intersect E, that's the two circles that I drew on the table, right? So D is the Democrat, so that's everything in the blue circle. And then E is the yellow, so it's everything in the yellow circle. So this D and E, okay? Democrat and executive means their intersection, right? Intersection is this box, the red triangle box. So there's a number 5 in there, right? Number 5 in there. So 5 employees are Democrat and executives. So the probability will be 5 over 140. Okay, 140. So that's the intersection case, right? That's the intersection case. So now what's the union case? So if they say D or E, so that will be union, right? Union. Okay, union. So that means we need all the small boxes except the total. We need all the small boxes in D and all the small boxes in E, right? So now let me draw some green circle. We don't have color green, right? Green circles, right? Those 4 small boxes. 1, 2, 3, 4. So without using an addition law, you just add all these 4 numbers, right? They are in E, the top 3. And then the 63 in the first column, also in D, right? Also in D. So solution 1. You could use 5 plus 34 plus 9 plus 63 divided by 140. Okay, you put everybody in column 1, everybody in row 1, except the total part. Okay, and then you add them, you got the numerator. Okay, you got the numerator. Okay, so this is one calculation, right? This is one calculation. So now there's another calculation, the solution 2, and then you got the answer, right? You got the answer. So solution 2, so let's change it back to red. So solution 2, for this part, P, D union E, we can use addition law, right? Addition law. So this will be PD plus PE minus their intersection, PD intersect E over 140. So this will be PD, numerator of D. No, we don't need those over 140. They already have 140 in the denominator. Sorry. Okay, so what's PD? PD is 68 over 140. PE is 48 over 140. And then minus their intersection, 5 over 140. Okay, 5 over 140. Okay. Okay, yeah. So you got the same answer 111, right? So you should get same answer 111 over 140. So we have two different understandings, two different calculations for the union case. Okay, union case. Okay, but the most important thing is this word, right? So I use the orange color. If they have this word or, that means union. They have used word and, that means intersection. Or means you put some small box together, right? And means you find the common box in that row and in that column. Okay, in that column. So that's the second case, right? That's the second case. So all these calculations, we have the same denominator, 140. Okay, 140. So only the last case, we will change the denominator 140, right? So last case, that's the given conditional probability, right? So let's say if this say B, E given D. So this means only consider D. Only consider D means only consider the first row, right? The first row. So now the row total will be your denominator. Okay, we only consider the first row, so we only consider those 68 people, employee, right? And then among those 68 employee, 5 of them are Democrats, so in this row only, E is 5. Okay, yeah. So we only consider D, and then among D, how many E? That's the meaning, right? That's the meaning. So let's try again. So if they say, what's the probability of R given W? Only consider workers. Right, so only consider workers. So this is our row, right? So the total workers, 92, we only consider those. And among them, 21 are Republicans, so it's 21 over 92. Okay, so only consider workers. So that's the notation for conditional probability. Okay, so this small bar means only consider, right? Only consider. And then in the next case, case 4, there is a multiplication law, there is an addition law, so we should use this conditional probability for the multiplication law. Okay, multiplication law. Okay, so now let's look at this the red part, multiplication law and addition law. Okay, and addition law. So these two laws will be given. Okay, will be given to you during the exam. So your job is we need to choose a law, pick a law for each question. Okay, pick a law for each question. And last time in the class I already explained, we look at the last part, the question part in the problem, right? In the problem. So now for 5.7, you look at the last part. Find the probability that a person exercises or drinks. So now what's the keyword? The keyword is this word or. Right? And then 5.8. So applicant is interviewed and admitted. So the keyword is and. Okay? Yeah. So or will give you addition law and will give you multiplication law. Okay? So this word give you these two laws, right? Yeah. So you look at what they want is or and. Okay? Or and. And then you pick the law. Okay, you pick the law. So after you pick the law, you should write down the law, right? You should write down the law. So let's focus on 5.7. So they have exercise or drink, right? Exercise or drink. So we already pick our law. So P, A or B is PA plus PB minus PA and B. So first you write down which law you picked, and then you write down what's A and B for this particular question, right? Particular question. So you look at the box, right? Look at box. So what's before and after the word or, that's your A and B, right? A and B. So A means some people exercise. B means some people drinks. That's the meaning of A and B in this probability, right? Probability. So now what is PA? Because we need PA, PB, PA, and B. We need to find these three numbers, put them together. We find we got PA or B, right? PA or B. So we need PA, PB, and P, A, and B. Okay, so only looking at the last sentence, we got all these informations. Okay, all these information. So now we try to look at the numbers in the given question, right? We need 3 numbers, right? We need 3 numbers. So now let's look at 45. 45 means the population exercise. Okay, exercise. So exercise is A, so PA is 45. Okay, and then the next number is 65. 65, drink. So has nothing to do with exercise, so it's part B, right? Part B, PB. And then the last number, 32, they said exercise, so this is A, and drink, B. So A and B, so this is 32%. Okay, so now what's your calculation for the A or B? So P, A or B is 45% plus 65% minus 32%. Okay, 32%. So that's 78%, right? That's 78%. Okay, so either drink or exercise, you have more people, right? You have more people, that's 78%. So that's the problem for addition law, right? Addition law. So the next question, so from here, the end, you can see that's the multiplication law. So this will be A, this will be B, right? Will be B. So P, A, and B. So for multiplication law, the hard part is you have to pick one multiplication formula, right? So it's either PA times PB given A, only consider A, or PB times PA, only consider B. Okay, only consider B. So you pick one of them, okay, not both. Okay, either this one or the other one. Okay, or the other one. And then how to pick? So first you write down just like before. What is A, right? A is interviewed. B is admitted. Okay, and then you look at the numbers. What's the meaning of those given numbers, right? The meaning of given numbers. So first, 14%. That means interviewed, right? So that's PA is 14%. And then you look at 3%. 3% means admitted, has nothing to do with interview. So that's PB is 3%. Okay, so now we have one number in this formula, that's PA, and one number in that formula, that's PB. Okay, that's PB. So now the next one will be important because that will tell us which formula is B over A, B given A, or A given B. Okay, A given B. Okay, yeah, so this sentence is the key, right? Is the key. So of those applicants interviewed, 20% are admitted. So this means if you only look at the people that was interviewed, so this means only consider interviewed. So only consider interviewed means only consider A, right? So this is P, B, only consider A, so that is the number 20% in this sentence. Okay, in this sentence. So now we have these two components in the middle formula. So this is our multiplication formula for the question, right? For the question. So P, A, and B is PA 14% times P, B only consider A 20%. Okay, 20%. Okay, yeah. So that's the idea, that's the formula. Okay, that's the formula. Okay, yeah. So it's 2.8, right? It's 2.8%. Okay, 2.8%. So that's it. That's our 4 cases for the probability. Okay, for